Graph the following semicircle. So the first thing we can recognize is that instead of having y in terms of x, which is usually the convention for when we write a rule, we've actually got x in terms of y. So when we discuss transformations and graph this rule, it's going to be a little bit different to how we're usually doing it. So it'll be important for you to keep that in mind as we go through this example. So if we inspect the rule, we can see that this negative symbol out the front means that we have the negative portion of the semicircle. And because it's x in terms of y, it means that our semicircle is going to exist alongside the y-axis this time. So next we're going to look at the transformations that have occurred to this semicircle. So the first transformation we can see is that this semicircle has a radius of 3 units. And that comes from looking at the 9 inside the square root part. And this gives the square root of 9 equals 3. So that will be the radius of this semicircle. Next we can look at the 3 out here and recognize that that is a translation of 3 units in the positive x direction. So again, usually the position here would be reserved for translations parallel to the y-axis, but because the rule is x in terms of y, that is now a translation parallel to the x-axis. So with this in mind, we know that we have a semicircle that sits next to the y-axis, we've got the negative part, and it is translated 3 units in the positive x direction. So that will place this semicircle in about this position here. And now we can label the key features, which include the axial intercepts and the endpoints. So this point here is included on the graph, so it has a coloured in dot, and that is going to be 3, 3. Down here, this point is also included, so it has a coloured in dot, and that is going to be x is 3 and y is negative 3. And finally, the x and y intercepts are the same point, and that is at 0, 0. So that there is the graph of this semicircle. On this slide, we've just got a computer to generate a more accurate graph of our semicircle, but you can see that all of the key features remain the same.